Data science is an amalgamation of different scientific methods, algorithms and systems which enable us to gain insights and derive knowledge from data in various forms. Various organizations like Google, Facebook, Uber, Netflix, etc. are already leveraging data science to provide better experiences to their end users. Although data science techniques have been conceptualized and in use for several decades now, the current demand for data science is fueled by the high availability of digital data and resources for computation. This course serves as an introduction to various data science concepts such as probability, statistics, linear algebra, machine learning, and computer science. At the end of this course, you should be familiar with the key ideas behind these concepts. By the end of this course, you should be able to understand what is data science, recognize why data science is gaining importance in today's business world, comprehend where data science can be applied in different scenarios across industry domains, understand major components of data science stack, learn how a data science project is implemented step by step in a given business use case. Why data science? In today's digital age, data is everywhere. From social media interactions to online transactions, we are constantly generating vast amounts of data. But what if we could harness this data to drive insights, make better decisions, and shape the future? That's where data science comes in. Few interesting facts about digital data. There are 40,000 search queries every second on Google alone, which makes it 3.5 billion searches per day and 1.2 trillion searches per year. In 2017, a staggering 1 trillion photos were taken and billions of them were shared online. By 2020, over 50 billion smart devices will be connected to collect, analyze, and share data. By 2020, universe of data will grow from 4.4 zettabytes today to around 44 zettabytes, or 44 trillion gigabytes. Let us now discuss a few business use cases where data science has proven to be indispensable. On-road integrated optimization and navigation. United Parcel Service, UPS, is a company that deals with logistical solutions for orchestrating the transport of parcel and cargo all around the world. UPS also utilizes cutting-edge technology to facilitate the management of businesses and to ease international trade. How did UPS achieve this? Orion, on-road integrated optimization and navigation, uses telematics and advanced algorithms to create optimal routes for delivery drivers, predicts maintenance requirements of delivery trucks to avoid breakdowns. What benefits did UPS reap? 29 million gallons of fuel saved, 364 million miles of driving avoided, 10 million minutes of engine idle time saved, 20 million package deliveries per day achieved. Fraudulent tax returns and identity theft. Internal Revenue Service, also known as the IRS, is responsible for collecting taxes, providing tax assistance to taxpayers, and pursuing and resolving instances of fraudulent tax filings. What did IRS use data science for? Stop identity theft, fraudulent tax returns, and improper payments. Reduce the tax gap between the number of people who are paying taxes and the number of people who should be paying taxes. Ensure core compliance with tax rules and laws. What did IRS achieve during the 2015 to 2017 period? 57% fall in number of confirmed identity theft tax returns. More than $20 billion in taxpayer refunds protected. Hospital Operations Management. Boston Medical Center, BMC, is an academic health science center in Massachusetts affiliated to Boston University. It provides medical care for infants, children, teens, and adults. How did BMC achieve this? Times they contracted with FTI, Forensic Technologies International Limited, consulting to develop an analytics framework. The framework allowed the medical center to look at each aspect of the hospital's operations and benchmark BMC's performance against standardized best practices. It allowed them to improve staffing and better track how resources were allocated, which helped them slow the revenue freefall. This allowed them to create a model that was sustainable, which ultimately improved patient care while keeping costs down, leading to a significant turnaround. Instant insurance and claims management. Lemonade Insurance Company is an American property and casualty insurance company headquartered in New York, offering renters and home insurance policies for homes, apartments, co-ops, and condos. Their offerings include a mobile app that tailors insurance deals based on the information that the customers volunteer. This app is embedded with their chatbot, which can further process insurance claims with minimal human interference. Here you see this picture and learn about Lemonade Insurance Company. Hello friends, welcome to Indiamoon. In this particular lecture we know what is data science. Data science is primarily a combination of data and science. According to Oxford Dictionary, data is defined as facts and statistics collected together for reference or analysis. According to the Science Council, science is the pursuit and application of knowledge and understanding of the natural and social world following a systematic methodology based on evidence. So, what is data science? Data science is an interdisciplinary field about processes and systems to extract knowledge or insights from data in various forms, either structured or unstructured, which is a continuation of some of the data analysis fields such as statistics, data mining, and analytics. Data science is the empirical synthesis of actionable knowledge from raw data through the complete data lifecycle process. Ref. NIST, the National Institute of Standards and Technology. From the above definitions, we can come to the conclusion that in order to harness the power of data science in today's business world, we need to acquire skills in various components to master the subject. Let us now discuss the major components of data science. From the above definitions, we can come to the conclusion that in order to harness the power of data science in today's business world, we need to acquire skills in various components to master the subject. Let us now discuss the major components of data science. In addition to these, we must acquire knowledge about the domain or industry vertical in which we plan to apply data science, such as retail, banking and finance, healthcare, e-commerce, life sciences, telecom, etc. Hello friends, welcome to Indiamoon. In this particular lecture we know what is probability. Probability is a mathematical subject which enables us in determining or predicting how likely it is that an event will happen. The probability of occurrence is assigned a value from 0 to 1. When the value assigned is 1, it implies that the event will happen with all certainty. On the other hand, when it is 0, it implies that the event is not likely to take place. Thus, we can be more certain of an event's occurrence when its probability is higher. What is statistics? Statistics is another mathematical subject which deals primarily with data. It helps us draw inferences from data by having procedures in place for collecting, classifying, and presenting the data in an organized manner. The analysis and interpretation of the refined data helps in providing further insights. Role of probability, statistics, and computation in data science. When studying and exploring an event, we make use of probability to quantify how likely it is that an event will occur. On the other hand, we use statistics to observe patterns in data samples to draw inferences about a population. We must note that statistics is not completely independent of probability, as statistical analysis involves probability distributions. Since both statistics and probability have their roots in mathematics, computation as a tool is needed to perform quantitative analysis. The use of computers is also necessary to perform complex calculations while processing the statistical data. Hello friends, welcome to Indiamoon. In this particular lecture we know linear algebra. Summary. Linear algebra is fun to learn. If not convinced yet, here are a few more reasons. Linear algebra makes scientific computing easy as most complex equations can be converted into linear equations with help of vectors and matrices, where we can view vectors as single-dimensional matrices. Linear algebra helps represent large sets of data as matrices, enabling us to better visualize the given data. All the operations processes performed on matrices are batch processes. This means we can process millions of data points simultaneously instead of processing each data point individually. What is machine learning? In 1959, Arthur Samuel defined machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. How can a machine learn? How can a machine behave like an intelligent entity? How can it learn and make decisions? These questions can be answered with the following definitions of machine learning. Machine learning is the field of scientific study that concentrates on induction algorithms and on other algorithms that can be said to learn. A computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T, as measured by P, improves with experience E. Why make a machine learn? Machine learning becomes essential when analysis on a given data by a human being has huge associated cost, time and effort. Note that we are talking about data that is huge in volume, with a lot of variety and coming with high velocity. Human intervention is not sustainable, e.g., if we want to navigate on Mars and we don't have the expertise available, we can make a machine learn and let it navigate on unknown territory without any human intervention. Human expertise cannot always be explained, e.g. speech recognition, image processing. A solution needs to be adapted to a particular case, e.g. user biometrics. Let us now discuss a few examples of machine learning. Digital recognition of handwritten notes. Mail needs to be sorted in the absence of human intervention. Addresses are written on mail in different handwritings. These handwritten notes can be recognized digitally by machines. Example 2. Face recognition. A person needs to be recognized based on their facial features. A machine is trained using a set of pictures. It can then recognize a person. Hello students, today we understand type of machine learning. There are 4 types of machine learning. First is supervised learning. Used in applications when labeled historical data predicts likely future events. Second is unsupervised learning. Used when historical data is not labeled and is used to discover unknown patterns in the data. Third is semi-supervised learning. Used in same applications as supervised learning. Uses both labeled and unlabeled data for training. Last, reinforcement learning. Works by discovering which action yields maximum reward through trial and error. Often used in robotics, gaming and navigation. Hello students, in this particular video we understand supervised machine learning model learning phase. A machine is taught to identify various fruits by building a model with the help of images. Supervised machine learning model testing phase. A new set of images is given to this model as test data so that it can classify different fruits. Supervised machine learning model evaluation phase. We should always evaluate a model to know whether it will do a good job of predicting the target, given new data points. One way to do so is to compute the ratio of correctly classified test data points to the total number of test data points available, thus determining the accuracy of the model. In our example, out of 8 test images, machine was able to classify 6 images correctly and 2 images incorrectly. Hence, accuracy of this supervised machine learning model is 6/8, i.e. 75%. Supervised machine learning model, summary. We can summarize our learning of the supervised machine learning as follows. In the first step, we train the machine with known data so that it learns something from it. In the second step, we expect the machine to utilize the knowledge it gained in the previous step and classify a new unknown data point. In the third step, the model is evaluated on the basis of how accurately it has classified the unknown data. Supervised machine learning model, types. There can be 2 types of supervised machine learning techniques as shown below. Classification, used to predict discrete results. For example, assume that a company wants to predict the budget period of a new project that they have acquired as short-term or long-term, based on various input attributes about the project such as the number of resources required, software requirements, hardware requirements, etc. We will need to use the classification machine learning technique here. Regression, used to predict continuous numeric results. For example, if we are trying to predict the approximate budget requirement of a new project that the company has acquired in actual quantifiable figures, based on various input attributes about the project such as number of resources required, software requirement, hardware requirement, etc., then we use the regression technique. Hello students, in this particular video we understand unsupervised machine learning model. There is a basket filled with some fresh fruits. The machine's task is to group similar colored fruits together. But here, unlike supervised learning, the machine is not exposed to any prior knowledge. So how will it arrange the same type of fruits based on their colors? Unsupervised machine learning model clustering. Machine identifies 4 clusters of fruits based on their color, as shown below. Unsupervised machine learning model, summary. We can summarize our learning of the unsupervised machine learning as follows. In the first step, we fix some variables or parameters based on which the machine will arrange the given data. In our example, we have taken color as the parameter. In the second step, the machine groups similar data points together. In our example, fruits with the same color are grouped together. Unsupervised machine learning model, summary. We can summarize our learning of the unsupervised machine learning as follows. In the first step, we fix some variables or parameters based on which the machine will arrange the given data. In our example, we have taken color as the parameter. In the second step, the machine groups similar data points together. In our example, fruits with the same color are grouped together. Hello students, in this particular video we understand semi-supervised machine learning. In real time, it may so happen that the unlabeled data points exceed the number of labeled data points in a data set. In order to fit a model to such data, we use the semi-supervised machine learning technique, wherein we perform the following steps. Step 1. Train the model with labeled data points only. Step 2. Use the above model to predict the labels of the unlabeled data points. Step 3. Combine the existing labeled data points with the newly labeled data points and use it to retrain the model. Step 4. Repeat the second and third steps until it converges. Applications of semi-supervised learning are text processing, video indexing, bioinformatics, web page classification, and news classification, among others. Hello students, in this particular video we understand reinforcement learning. Reinforcement machine learning algorithm is a reward-based and immediate feedback technique. Here, the machine's goal is to maximize the numerical reward at each and every step. In the process of learning, the machine is not provided any supervision as opposed to the previous ML algorithms we discussed till now. Instead, the machine is expected to figure out the optimum actions which will reap the maximum reward at each step, all on their own, without any interference. The actions that the machine takes at each step might not only affect the immediate reward but may also affect all the subsequent rewards. The ultimate aim is to reach the max possible reward in the least amount of steps possible. Thus, trial and error search methodology and immediate feedback in the form of a numerical reward are the two main characteristics of reinforcement learning. An example of reinforcement learning would be when a machine, learning to play chess, decides whether a move is right by planning the possible moves, anticipating the corresponding counter moves, and finally choosing one based on reward-based appeal for a particular position or set of moves. Another example could be when a trash collecting bot's charge is about to reach critical levels and it needs to make a decision to clean one more room before reaching out for the charging station or to immediately rush to the nearest charging station. The decision taken by the bot depends on the ease with which it can reach the charging station, based on its prior knowledge. Hello students, in this particular video we understand computer science in data science. Integrating the blocks of data science. To solve a given business problem, various blocks of the data science stack are tightly coupled with each other. Core algorithms need to be written in some programming language for implementation. Most algorithms use the basic concepts of linear algebra. Statistical computations need to be done on the given data. Available data in structured, unstructured, and semi-structured form need to be managed through various data management systems. Computer science provides us with the necessary programming languages, database management systems, statistical analysis, and machine learning tools. Tools and packages for data science. Following are a few tools and packages available which enable the application of data science solutions on huge amounts of digital data. Hello students, in this particular video we understand data science process and architecture. Putting the concepts together, data science process. Historical data or past data from various sources are cleaned and subjected to feature engineering. Feature engineering is the process of using domain knowledge to select or create significant features from the historical data relevant to the problem statement. This engineered data is divided into two sets, trained data and test data. Data science models are built using trained data, and then the performance of the model is evaluated on the test data. This validated model is used for taking various decisions on new unseen data points. Putting them all together, data science architecture. See this image now to understand all thing. Thank you. Hello students, in this particular video we understand data science project life cycle. The complete life cycle of a data science project is shown below. Define the goal, identify the problem to be solved. Collect and manage data, identify the information needed. Build a model, find patterns in the data that leads to the solution. Evaluate model, validate whether the model solves the problem. Present results and document, establish how the problem can be solved. Deploy model, deploy the model to solve the problem in the real world. Step 1. Define the goal. The first and foremost step in any project is to define a clear goal. Hence, at this point, it is important to learn every minute detail about the project, such as why is the project being started? What is missing currently and what exactly is required? What are they currently doing to fix the problem? and why isn't it working? What all resources are needed? What kind of data is available? Is domain expertise available within the team? What are the computational resources available required? How does the business organization plan to deploy the derived results? What kind of problems need to be addressed for successful deployment? Bad loan use case. Define the goal. The goal is to lessen the bank's losses caused by bad loans. To do this, the firm intends to create a tool to help the bank's loan officers to improve their accuracy in identifying bad loan applicants, thereby lowering the number of bad loans being authorized. For this purpose, the goal defined should be to the point and unambiguous. For example, a goal which states we want to reduce the rate of loan charge-offs by at least 10%, using a model which predicts whether loan applicants are likely to default is preferred over we want to get better at finding bad loans. Step 2. Collect and manage data. Now that the goal has been set, the next step is to find, explore and clean the data necessary for analysis. This stage takes up a lot of time but helps in finding answers to many important questions such as: what all data is available? Will it help in solving the problem? Is the data enough to carry out analysis? Is the quality of data up to the mark? Bad loan use case. Collect and manage data. Collect the data about each loan application with relevant attributes such as status of loan, duration, credit history of the applicant, present employment status, residing at an address since, number of dependents, and the number of active loans under the applicant's name. Collect the data across a reasonable span of time such as 1 year or 1 decade. Conduct initial exploration, using data visualization and summary statistics, and clean the data. While refining the data, it may so happen that the data identified earlier turns out to be not adequate to perform the analysis. There might also be a situation wherein we encounter various new problematic areas within the data, which we disregarded as not being a problem at all previously. For example, if the data set we took contained most of the defaulters or just a few defaulters, our analysis may result in a biased conclusion. Step 3. Build a model. Once the data is ready, the next step is to find meaningful insights from the data. Depending on the nature of the business problem we are dealing with, we can make use of any of the following data modeling techniques to gather such insights. Classification, determining which among the given categories a data point falls under. Scoring, predicting or estimating a quantifiable value. Ranking, ordering the data points depending on the priorities involved. Clustering, grouping similar items based on certain parameters. Finding relations, finding associations between various features of the data. Characterization, creating plots, graphs and various reports for understanding the data better. Bad loan use case, build a model. In the bank scenario, the problem we are dealing with is classification. We wish to classify bank customers who apply for loans as probable defaulters or non-defaulters. Hence, we need to train our model in such a way that it covers the entire range of the available data, thus enabling it to learn about most of the probable loan defaulter cases. Given the preceding requirement, we decide on a suitable approach to build the model. We can choose from either logistic regression, naive Bayes, k-nearest neighbors or decision trees, among other available classification techniques. We also need to be aware of why a model is taking a particular decision and how confident it is in its prediction. Ultimately, our model should be able to answer the question, how likely is an applicant to be a defaulter? Step 4. Model evaluation. Now that we have built our model, we need to determine whether it meets our goals by asking the following questions. Is the model accurate enough for our needs? Does the model meet the expectations? Is it better than the methodology being currently used? If for either of the above questions, the answer is no, we need to revisit the previous steps. Bad loan use case, model evaluation. Check whether the evaluation parameters from the suggested model apply in our scenario. Proceed to calculate the model evaluation parameters, such as accuracy and precision, based on the predefined rules and observe how many predicted values match the actual values. Step 5. Present results and document. At this stage we have achieved a desirable model. A model that meets all the requirements and goals we set for ourselves at the beginning of the project. The next step is to showcase the project to various audience as follows. Present the details of the model to all the collaborators, clients and sponsors. Provide everyone in charge of usage and maintenance of the model, once deployed, with documentation that covers all aspects of the working of the model. We must keep in mind that each group of people involved in the project require different kind of treatment when it comes to presentations and providing documentation. Hence, specific data visualization techniques must be used for each of them. What might work for one audience might not work for the other. Bad loan use case, present results, and document. In the bad loan scenario, we need to showcase the efficacy of our model to the bank officials. For example, if our model is able to identify a set of bad loans that amount to 36% of the total money lost to defaulters, we need to emphasize the same in the executive summary. In addition to this, any interesting insights uncovered such as, new auto loans are more riskier than used auto loans, or less losses are tied to home loans, must also be presented. Step 6. Deploy model. The last and final step is to deploy the model. Usually from this point ahead the data scientist is no longer associated with the operations of the model. But before they are off the job they must make sure that the following are in place. The model has been tested thoroughly and generalized well. The model should be able to adjust well to unforeseen environmental changes. The model has been deployed in a pilot program and any problems that cropped up in the last moment were taken care of by updating the model accordingly. Bad loan use case, deploy model. There may arise a situation wherein experienced loan officers might veto the decision taken by the model that we created as it opposes their instincts. Hence, we need to be always on the lookout for which is correct, our model or their intuition. Thank you friends. Hello students, in this particular video we understand Data Science Project Life Cycle. The complete life cycle of a data science project is shown below. Define the goal, identify the problem to be solved. Collect and manage data, identify the information needed. Build a model, find patterns in the data that leads to the solution. Evaluate model, validate whether the model solves the problem. Present results and document, establish how the problem can be solved. Deploy model, deploy the model to solve the problem in the real world. A clear, verifiable and quantifiable goal. 2. Set realistic expectations for all stakeholders. An unbiased data set covering examples that are sufficient to represent the entire data. The right model based on the business scenario. 5. Correctly represented and deployed model in order to meet the predefined goal. Hello students, in this particular video we understand Data Science Top 10 Real-World Use Cases. Each of the above use cases are briefly described. Churn prediction. Churn implies loss of customers to competition. For any company, it costs more to acquire new customers than to retain the old ones. As churn prediction aids in customer retention, it is extremely important especially for businesses with a repeat customer base. The application of this model cuts across domains such as banking, e-retail, telecom, energy and utilities. Sentiment analysis. Also referred to as opinion mining, it is the process of computationally identifying what customers like and dislike about a product or a brand. A domain which relentlessly makes use of sentiment analysis is the retail industry. Companies like Amazon, Flipkart, Reliance, Paytm use customer feedback from social networking sites like Facebook, Twitter, etc. or their own company websites to find out what their customers are talking about and how they feel, i.e. positive, negative, or neutral. They leverage this information to reposition their products and provide better new services. Online advertisement. The incremental growth in the complexity of ads industry is due to the ease of access to the internet via a wide variety of devices around the world. This gives the advertisers an opportunity to study user preferences and online trends. The insights offered to them through these analyses translates to actionable items on issues and opportunities such as reducing ad blindness or optimizing cost per action, CPA, and click-through rates, CTR. Recommendations. Many e-retail companies like Amazon, Netflix, Spotify, Best Buy, YouTube, among many others, use recommender systems to improve a customer's shopping experience. This offers the companies a chance to gather information on customers' preferences, purchases, and other browsing patterns, which lend insights that can amplify their return on investment. Truth and veracity. In today's digital world, the quantity of fake news is on the rise. Not only does vast majorities of population fall prey to misinformation, but it affects businesses negatively. Data science is being used to ensure data veracity, or in other words, verify the truthfulness of data based on both accuracy and context. Companies such as Facebook, Twitter, Starbucks, Costco, and many others are combating fake news currently with the help of various data science techniques. News aggregation. A news aggregator gathers and clusters stories of the same topic from several leading news websites and also traces the genuine source of a news item and what is the course of the story. It has a special interactive timeline that allows the reader to flip swiftly between headlines, refining their search by country or by specific news sites. Notable examples include Google News, Reddit, Flipboard, Pulse, etc. Scalability. Scalability refers to an enterprise's ability to handle increased demands. In the corporate environment, a scalable company is one that can maintain or improve profit margins while sales volume increases. Many a times the process is slowed down by human intervention for decisions. For example, the credit operations in banks invest substantial time in assessing the credit worthiness of a client. Client management teams take long time to suggest the right product to the customer, suggest alternatives. The client help desk takes long time to provide the desired info to the client. If these processes can be automated, the business can scale up. Data science helps build systems like recommender systems, chatbots, etc. to achieve scalability. Content discovery search. Content discovery involves using predictive algorithms to help make content recommendations to users based on how they search. Search engines such as Google, Bing, and Yahoo, and various other platforms are now using intelligent learning mechanisms to understand user preferences to be able to suggest content that's most suitable for them. Few more platforms that use content discovery algorithms are Facebook and YouTube. The content that appears in an individual's Facebook news feed and the videos that appear in the recommended for you section of YouTube users' account are both altered according to each user's past behavior and personal preferences. Intelligent learning. Intelligent learning has become a part of our day-to-day lives in various forms. For example, Google Maps uses undesignated location data from various smart devices to predict the flow of traffic in real time. It also utilizes user-based reports on incidents that might affect the traffic, like road construction and accidents, to help suggest fastest routes for travel to users. Another example would be ride-sharing apps like Uber and Ola. They optimize the ride experience by not only minimizing the ride time but also by matching users with other passengers for least amount of detours in shared rides. Other examples of intelligent learning include self-driving cars, smart email categorization, credit card fraud detection, etc. Personalized medicine. In many cases, the success of a particular treatment for a patient's condition cannot be predicted beforehand. Thus, many medical practitioners follow a non-optimal trial-and-error approach. In personalized medicine, a doctor needs to study an individual's genes, environment, and lifestyle. This would help tailor treatments for specific medical conditions as opposed to a trial-and-error approach. This would also enable pharmaceutical researchers to create combination drugs targeting a specific genomic profile, which in turn increases safety and efficiency. Companies that are active in the field of personalized medicine are Roche, Novartis, Johnson & Johnson, among others. Thank you, friends. Hello students, in this particular video we understand data science ecosystems. Data science solutions as a product are offered by various vendors in the market today. Few of the popular vendors are as follows. Learn this image and know more about this. Hello students, in this particular video we understand data science ecosystems. Data science solutions as a product are offered by various vendors in the market today. Few of the popular vendors are as follows. Learn this image and know more about this. We can observe in both data analytics and machine learning fields, IBM Watson emerges as the top player. Platform comparison. A consolidated view of the platform comparison based on data science technologies is shown below. In this course, we have explored and understood the following. Why data science is the need of the hour? How to align the data methodically to our business advantage? What is data science? Different components of the data science stack: probability and statistics, linear algebra, machine learning and computer science tools and packages. Data science project life cycle. Characteristics of a successful data science project. Top 10 use cases of data science. Data science ecosystems. Data science technology popular players. This lecture we cover basic data science. If you like this, please like and subscribe Indiamoon. Thank you friends. Happy coding.